Okay, so the screen is visible to everybody, I guess. So we were doing one problem in Khoslas theory. Through Khoslas theory, we are doing one problem, right? We will be completing that problem today. So this was the problem. Yes, this was the problem. Okay, so you have seen that we have calculated the values of phi E1. Phi E1 is actually 100. It has not been calculated. It should be 100, and your phi, this one is 100. Okay, at this point it is 0. So the rest of the 7 points needs to be calculated. Okay, so for that purpose we have calculated, for this file we have found out the values at this point, right? We have found out the values, that is phi d1 and phi c1. We have already done that, and after that actually through calculation we have found out the pressure at this point. So after calculating all the results, after that we have did some corrections for the phi c1 value. The phi d1 value, it won't be changed. So this one there is no need of correction at this point. Okay, but the phi c1 value, that will be changed. There needs to be some correction. So we have seen that what are the corrections for this point. One is for the influence of this file, due to the influence of this file, and another is for the thickness of the floor, because you are finding out the pressure percentage at this point, right? But actually your floor is means your pile is starting from below this, means the width of the floor, below the just the bottom fiber of your floor. You need to calculate the pressure, not above it. So this pressure, this will be calculated through correction of two values. That from the original value that we got, there needs to be two correction. One is for the influence of this file, another is for the thickness of the floor. Okay, so we have found out these values. Next up we had to find these values, that is E2, C2 and D2, the 5 values at these 3 points. For that purpose we have already seen there is one formula. For the intermediate pile, we have seen that these are the there is this formula. Okay, so considering that, firstly we have to determine the value of lambda 1 and lambda 2 from alpha 1 and alpha 2. From that we will be getting the value of lambda and lambda 1. Okay, so the b1 is the distance of the intermediate pile from the your upstream pile, and b2 is the distance of the intermediate pile from the downstream pile. So from the diagram we can easily get the value of b1 and b2. So from that we will be able to get the value of alpha 1 and alpha 2, and from this you can easily get the value of lambda as well as lambda 1. So accordingly you can find out the values of phi e, phi d and phi c. These values you can find out, right? But there is also another approach, that is graphical approach of finding out the values. This is more, the mathematical approach is more means it is more accurate. Okay, but in case of graphical method there may be some parallax error or something like that may be happening, or also interpolation needs to be done. So for that purpose it is not much accurate, but these calculations is quite time consuming and it is cumbersome. So in order to avoid that, what we do, we do use the graph. Okay, so one procedure is obviously using these formulas to find out the pressure. You can see that phi e, phi d, phi c, there are all formulas for that, through which you can easily be able to find out the value of pressure heads at this or the percentage pressure percentages at these 3 points. Okay, but if you use the graphical method, how this I don't know how much of it is clear to you, because it is quite hazy, this picture. So for that purpose just I am telling you. If you have any doubt you can ask me. Okay, so how from the graph it is being tackled out? Look here, in this part, previous part, we have seen that this is the for single pile, means for the cut-off piles, this is the graph. Okay, that is the there is curve 11.1a, there is a curve. If you, this will be provided in at the time of your exam. These graphs will be provided, this graph and this graph, these are two different graphs. You can see this will be provided during the course of your exam, okay. But in this curve you can see that how the values are calculated, the phi c1, phi d1, how these are calculated. These are calculated, this axis represents your 1 by alpha, okay. This is 1 by alpha, and these are the curves. For this one is for phi e, you can see that this is for phi e, okay, and this one is for phi d. So this one is for phi e and this one is for phi d, okay. So from that, how will we be able to calculate the value of phi e? I have already discussed it with you people, that how we will do it. We know the value of alpha, so we will be getting the value of 1 by alpha. So we have to locate the point on this axis, okay. Then we will be just dropping out a perpendicular on the two curves. This one is not required, just omit this curve. This curve is not required, okay. So we will be dealing with only this curve and this curve, okay. So for that purpose, we know the value of alpha. So 1 by alpha will be known to us. So we have to locate that point on this axis. Then from that we will be dropping a perpendicular to these two curves, okay. So the your y axis ordinate will give us the this value, that is phi e or phi d accordingly, okay. So you know, once you will be able to get the value of phi e. Here you can see the on this curve, again a horizontal is being drawn, and this value turns out to be 29. So your phi e value is 29. So from that phi c1 you can see that 100 minus phi e, that is 100 minus 29. In this way it has been calculated. Similarly, the your y axis coordinate will give us the value of, for this curve will give us the value of phi d. So phi d1 is 100 minus phi d, that gives us your this one is 20. You can see that this perpendicular is being dropped, and from that 20, this is 20. So we have got the value of 20, that is phi d. So 100 minus 20, it is 80. So in this way it has been tackled out through this curve, that is plate A. This is known as plate A, okay, plate A curve. So from the next how this next curve is being executed, this is plate 2, okay, or plate B you can also say. This is this particular curve is used for determining your pressure heads at in the or at the junctions of your intermediate piles, okay. This one is needed for the end piles. This one is needed for the end piles. You can see this figures are there, right? This denotes your end piles, right? So for the upstream pile as well, means for this pile as well as for this pile, we will be using this curve, whereas this one you can see, this is the image of an intermediate pile. So this curve will be used for intermediate pile, for determination of the pressure heads at the intermediate pile. So you can see that, right? So how this has been used from the graph? Look, these each lines, you can see there are curves, right? So these are the curves that represents your alpha value. This small, not able to zoom, you won't be able to see if I zoom it, okay, but actually these are the values, this particular are the values for alpha, okay. Everywhere you can see a small thing is written. If you have a closer look at the graph, you will be able to get it more properly, okay. So for that purpose, look at this, these are the values of alpha, okay. Here 1 by alpha, there was 1 by alpha, right? For the previous curve we have seen that there was 1 by alpha, and it represented along your x axis. But here the alpha value, there is no function of 1 by alpha. Here there will be the function of alpha, and that alpha value is denoted in terms of curves like this, okay. These are individual curves having different alpha values. There is a set of alpha values, and there is another set of alpha values. These are again another, like this one is suppose alpha equal to 0 1, okay, this one is alpha equal to 2. In this way this has been going up, okay, and here if you see this is alpha equal to 1, this is alpha equal to 2, in this way. Okay, so this is this is one set of your alpha values, this is another set of your alpha values. So next what we will be doing, we will be finding out the b1 value, b2 your b1 and b2 values. So from that we have to determine the value of b1 by b and b2 by b. Just try to understand this part. If you have any problem you can stop me anywhere and ask me, okay, because this graphical method is quite cumbersome. So what we will be doing, we will be finding out, we have for this formula also we need to find out the b1 and b2 value, but no need to find the b1 by b value, okay. B is the total flow length, so b1 by b is not required, neither your b2 by b is required. Only for that purpose you need to find b1 by d as well as b2 by d. But for the graphical method what you need to find out is b1, you can see this b1 by b and b2 by b, these two values have to be determined, okay. After that what we will be doing, we locate the alpha value. Your alpha has turned out to be 9.5, so here we have to locate the alpha value. I do if you see the graph you will be able to see there is no part of 9.5. you see that here it is 9.5, but none of the values are resembling your 9.5 value. So for that purpose what you have to do, there will be a value of alpha equal to 9 and alpha equal to 10. So you have to draw, we have to draw an intermediate curve, imaginary intermediate curve, okay. So that will be 9.5. just try to get, there won't be any value of alpha equal to 9.5. there will be a value of alpha equal to 9 and alpha equal to 10. So intermediate will be getting a value of alpha equal to 9.5. you have to imagine that there is an imaginary curve like that, that follows the pattern of your alpha equal to 9 and alpha equal to 10, okay. So for that you have to draw, imagine that line is there. So after that what you need to do, you have to locate the, this axis represents your b1 or b2 divided by b, okay, b1 or b2 divided by b. So for the first purpose, that is for determining your this value phi c2 value. What is the phi c2 value? This one. For this part always remember this will be dependent on b1, okay. For the graphical value, for the graphical way of tackling the problem, this phi c, this will be dependent on your b1 value, and this phi e and phi d, this will be dependent on just ignore this, this will be dependent on b2 value, okay. This will just be the opposite. You see that this one is the b1 value, so your phi c will be dependent on b1 value, and your phi e and phi d will be dependent on this b2 value, okay. This is just your opposite, okay. So for that purpose what you need to do, you have to locate, for determining the, as I have told you, your phi c2 value is dependent on b1 value. So what will be it will be b1 by b1 by b. So for that you have to determine the value of b1 by b. For determining your phi c2 value, you have to locate that point on this axis, okay. You have to locate the point on this axis. What is the b1 by b value? That turns out to be 0.298. so roundabout it can be said it is 0.3, okay. So you have to take the point, we have to locate the point 0.3. you can see that 0.3 is being located. It will be close to 0.298, will be close to 0.3, so you can approximate it to be 0.3. So from that 0.3 is located. Next we have got the value of we have got the curve for alpha equal to 9.5. it may be you can take it alpha equal to 10 for that curve also, because those are quite close, those curves are quite close. So for that purpose you can assume it alpha equal to 10 also, or the for better results you have to imagine a imaginary curve that will be running between alpha equal to 10 and alpha equal to 9. Okay, so what you have to do, you have to draw a perpendicular from this point. From b1 by b you have to draw a perpendicular to your alpha equal to that particular value. Okay, so after that we will be drawing the horizontal. So that particular this location, this particular location, here will give us the value of phi c2. This axis represents your phi c value. Okay, this represents your phi c value. Just remember this. This represents your phi c value, and this axis represents your phi d value. Okay, so what we will be doing? We will be locating the b1 by b point. Then we will be drawing a perpendicular to the curve of alpha equal to some value that we have calculated. So from that we will again draw a horizontal, and the axis it intersects that particular value, the ordinate value will give us the value of phi c2 from the curve, right? You can see that it turns out to be 56%. So the phi c2 value is 56%. Okay, in this way your phi c2 value we have got it. Okay, next part is for determining your phi e and phi d. Okay, so how to determine your phi d? I have told you, firstly just look how phi d2 is determined. So this represents your phi d. I have told you this represents your phi d value. Okay, so what we will be doing, we will be, for this purpose I have told you, we will be taking the point we will be taking the this axis b2 by b. I have told you this phi e and b c2, this will be dependent on E and D will be dependent on B2 value, right? E2 and D2 will be dependent on P2 values. So for that purpose what we will be doing, we will locate the point B. Similarly we will be locating the point B2 by B on this axis. It turns out to be 0.7. You can see that it has been calculated to be 0.702. So round about it is 0.7. So from that we have to locate the point, and on this axis this will be dealt on this particular curve for your phi d value. Okay, this set of curves will be required for phi d value. Just remember this, as because this is phi d, this axis represents your phi d value. So this set of curves will be determined, this set of curve will determine your phi d value only. Okay, this won't be determined, phi e2 won't be determined through this curve, only your phi d will be determined, because it represents your this set of curves represent your phi d value on this axis. Okay, so for that purpose again what we will be doing, there are alpha values, alpha will remain the same, that is 9.5. Similarly we have to draw a perpendicular, and from that we have to draw the horizontal, and it turns out to be 37. So your actual what will be there, it will be 100 minus, it is given in the formula itself, that will be 100 minus phi d value. Your phi d2 value will be equal to 100 minus phi d, that is, you can see that it is 37. So 100 minus 37, it turns out to be 63. Okay, so in this way from the curve you can get the value of phi d2. And how phi e2 has been calculated, you will get it from b by 2 itself, but remember there is one formula that is already given, that is phi c equal to 100 minus phi e, right? This is already there, this you have already studied. So how, what will be the value of phi e? Phi e equal to 100 minus phi c. Okay, so for that purpose we have to determine for determining the phi e value, this value, we have to determine the phi c value. So what will be the phi c value? But this overall process of determining phi e value will be dependent on your b2 value. So from the b2 by b, that point only you have to draw a perpendicular. Okay, we have to draw the perpendicular on this set of curve, because this set of curves represents your phi c, this represents your phi c, right? And this set of curves represent your phi d, I have already told you. So we have to locate the same curve, that is 9.5, that alpha equal to 9.5. same curve, it has been this curve, okay. So we have to draw a perpendicular from this to this curve, then we have to draw the horizontal like this, and it turns out to be that phi c value turns out to be 30. So what will be the value of phi e? It will be 100 minus phi c, that is 100 minus 30, and that turns out to be 70. In this way, from the curve you can get the value of phi E2, C2 and D2. Just let me know whether you have understood it or not. From the curve, have you understood? Yes or no?
Yes, sir.
Okay. So these have been determined. Now for the next part we need to do the corrections. I have already told you that for the corrections what we need to do, we have to consider the value of d, either small d or capital D, any value. We have to consider it, that d value from the bottom fiber of your floor, not from the top fiber of your floor. The top fiber of your floor, that will be considered only for determining these particular terms, okay. We will be able to get the value of these particular values, these 5 values, while calculating that we will be considering it from the top fiber. But for the correction part, as you know, we are going for the correction part, so the total floor will be considered for that. So you can see that it has been calculated, we have already got this value. So d by capital D is the depth of the influential pile, that turns out to be 153 minus 148, because your pile was like this, this was your floor, it had 1 meter thickness, right. This length was 5 plus 1, this was 6, right. From the top fiber it was 6, and this one is also having the same length. So from that we can easily get the value of this, all values you can get, okay. And here it will be negative, because why it will be negative? Correction, because your influential pile, this one is the influential pile. While finding out the pressure at this particular points, we are considering this as influential pile. So this is located on the upstream side. Once it is located on the upstream side, there will be a negative correction, I have told you. So this turns out to be negative. Next part is correction of V2 due to the thickness of the floor. We will do the unitary method. I have already told you we will be doing the unitary method. Here we have found out the pressure, that is phi E has been calculated to be 70, right. Yes, it has been calculated to be 70. And what is the value of phi D2? That is 63. So there will be somewhere here, this will be less than 70. So here by unitary method we will be subtracting it from 70, okay. So here also it will be a negative correction. You can see that this one is also negative correction. So there is no slope here for this part, there is no slope, it is horizontal. So there won't be any correction due to the slope for E2. So you can see that from 70 we have deducted these two values, these are the corrections, okay. So these two values have been deducted, so it turns out to be 66.95. So your this value, this is phi E2 value, you have calculated it, okay, and it turns out to be 66.95. Next correction, this one there won't be any correction for the D2 value, this part there won't be any correction. You can see that here there won't be any correction, okay, this is already okay. But here you need to do a correction. What are those corrections? Look, if you refer to the original figure, you can see that here you need to do all the 3 corrections, because there is a slope between this pile and this pile, there is a slope, right. There is a slope, there is the thickness of the floor, it is in every case you have to consider that, and the influence of this pile is also there, right. So for that purpose you need to do all the 3 corrections. one by one. Okay, so first one is for the, you can see first one is for the influence of the downstream pile. So for that purpose what we will be doing, we will be, I guess I have told you, we will be considering this from this fiber itself, the depth of this file, the depth of this pile will be considered from this point. Okay, just try to get this one, the depth of the pile will be considered from this bottom fiber of your floor itself, and your this pile will also be considered from that. Okay, so we don't have to consider this from this fiber, but we will be considering the sorry for no sorry, just wait. While calculating the phi E3 value, then we will be considering it from this fiber. Otherwise, this is just the reverse. While considering the depth of this pile, we will be considering it from this fiber. Okay, we will be considering it from this fiber. But in case of phi E3 value, that time our reference line will be this one. Okay, so we can see that this pile, the influential while calculating the phi C2 value, our influential pile is this one, right? So the what will be the value of depth of this pile, it will be calculated from this point. Okay, from this point what will be the value, that is 153. This is having a reduced level of 153, right, and this one is having a reduced level of 151.7. so 153 minus 141.7, it turns out to be 11.3, right, it turns out to be 11.3. You can see that it turns out to be 11.3. so here there needs to be one correction, this is wrong, this is not 11, it will be 11.3. here also it will be 11.3. okay, this is wrong, it will be 11.3. just you correct this, you just have a look at this, this will be 11.3, the value of capital D. Okay, and the value of small d will be your depth of the pile 2, that is 5, already we know that it is 5. okay, so it turns out to be 20, just have a look whether it is 22.89 is coming or not. This correction will be there, it won't be 11, it will be 11.3. okay, so the you have got this correction, suppose it turns out to be 2.89 itself. So here it will be as the influential pile is on the downstream side, so here it will be a positive correction. Okay, I have repeatedly told you that if the influential pile is on the downstream side, it will be a positive correction, and on the upstream side it will be a negative correction. So this one will be a positive correction, you can see that. Okay, so just correct this, it will be 11.3. next part is due to the thickness of the floor. So how it will be, again done by unitary method, no need to mention that. You can see that here it will be a positive correction only, because why this will be positive, because the, if you look at this, just refer to the original diagram, here the pressure is found out to be something more than something less than this pressure. So somewhere in between, this is in between, so at this point it will be more than this, because as you go up the pressure is being reduced. Suppose this turns out to be, you have found out this value to be 50, just suppose, and this turns out to be 60, so somewhere down it can be 52, so it has to be more than 50, right. So here you need to do a positive correction. On the as I have already discussed, on the downstream side of the pile, due to the floor thickness, you have to do a positive correction. So here you need to do the positive correction, you can see that. Okay, so similarly your unitary method has been carried out for this part, you can see that it turns out to be 1.17. okay, so the next part is correction due to the slope of the floor. So you can see between the two piles, that is these two piles, between these two piles there is a slope of 1:3, right. So due to this slope, what will be the correction, this slope is going upwards, so there is a increase in area of water. So as the area is increasing, required quantity of water is getting more space, so they will induce less pressure at this point. If this was horizontal like this, pressure would be had been more, but once you release it like this, you can understand as pressure is equal to force by area, so area is increasing, so the pressure will be less in that way, right? So they have, due to the slope, it will be a negative correction. What will be the correction? For 1:3, the correction factor is, you can see from this table, 1:3, that is V is to H was 1:3, so H is to V is 3:1, so the correction factor is 4.5. This needs to be multiplied with the horizontal slope. You can see that it is to be multiplied by the horizontal length, that is your 3, and divided by the distance between the two pi lines. What is the distance between the two pi lines? That turns out to be 40. So it will be, what will be the value? It will be 4.5 into 3. 3 is the horizontal length, you can see that, divided by 40. Okay, so this will be the value of, you can see horizontal length is 3, right? You can already see that it is 3. So this is why your 3, this value is coming 3, horizontal length, and divided by 40 is the distance between the pies. This has only been carried out. You can see that from this part, what is the value? 4.5 into 3 divided by 40. So this one will be negative correction. So in total, you can see the total computed value is comes out to be the original value plus those two corrections are positive, but this one is negative. So in turn, it turns out to be 59.72. So your total calculation for your intermediate pile is done. After that, at the end, you need to calculate for the downstream pile also. So for this purpose, we will be considering the the depth of the pile. For determining the phi values, we will be considering it from the top fiber, because we are considering it of negligible thickness. Okay, so from the top fiber, you can see that it is 152 minus 141.7. So we will be taking this fiber as our reference. Okay, so there it turns out to be 152 minus 141.7. So you can see it is 10.3. Okay, so 10.3 is the depth of this pile. So from that you can easily get the values, either from curve you can find out, from the graph you can find out, or also from the formulas you can also find out. Okay, so here you can see that it has been done from the graph itself, right? Yeah, you can do it by the formula also. So your phi c value, phi c3 value, this will be 0. I have already told you. Phi d3 and phi e3, this can be calculated using these formulas, or also you can do it from the curve, because once you know the d and b value, so d by b is the, b by d is the value of alpha. So your 1 by alpha is d by b, right? So it turns out to be 0.181. So you can draw from the plate A curve, you can easily do the same procedure as you did for the upstream pile. You can draw a perpendicular like this, and to the two curves, you can see that you can draw a perpendicular like this to the two curves, and from that you will be able to get the value of phi d and phi e. Okay, this will represent your values. So these have been carried out. Next part is the correction for E3. This part, there needs to be a correction for this part only. There need not to be any correction for these two. So what are the corrections for these two? You can see the slope is horizontal at this point, but there needs to be two correction. That is, one is for the thickness of the floor, and one is for the influence of the intermediate pile. So this is for the intermediate so influence of the intermediate pile. You can see the pile number 2 is acting as the influential pile. So for that purpose, as I have told you, look at the depth of pile number 2 is 150.7 minus 148. How it is coming? 150.7 minus 148. Look at this original diagram. in US, just hold on. 150.7 minus 148. Okay, so 150.7 minus 148, the influential pile. You can see we will be taking the fiber from this. I have told you already for this point we will be taking the fiber from this. So what is the value? 152 minus 1.3, that turns out to be 150.7. so 150.7, that is, this is having a reduced level of 150.7. okay, so 150.7 minus 148 will give us the depth of this pile. We have to find this value only for the depth. Okay, for this purpose, similarly, what will be the value? You can see that from the what is being calculated. You can see that the value of the your that particular pile, it turns out the small d is 150.141.7. so for this purpose, what we will be taking, just have a look, we will be taking it from this bottom fiber. From this fiber, for considering the depth of this particular pile, we will be taking it, as you can see, your floor is up to this, at this point, right? We will be taking it from this point. So it turns out to be 150 minus 141.7. so your small d turns out to be this value for this particular pile. So we can easily get the value of the correction required for this part, for the phi E3 value. So this will be negative correction because it is on the your influential pile is on the upstream side, right? So this one will be negative. You can see that this is negative. So after that, we will again do for the floor thickness through unitary method. The same procedure will be followed, and we will be able to get the value that is calculated to be 1.51. So there is no correction for the slope, because you can see at that particular juncture there is no slope, the floor is horizontal. So there is no requirement for correction due to the slope. So in the end, what we will be doing, we will get the computed value and we will do the corrections, and it turns out to be 35.47. okay, so this is the compilation of all the results we have got. Okay, so this is the compilation, and at the end what we need to do, we have to calculate the exit gradient. How we will be able to get the exit gradient? We know this particular formula, we have already discussed, right, about this particular formula, where H is the maximum seepage head. So what will be the maximum seepage head? That will be the maximum difference of seepage. So what will be the value? If you look at this particular diagram, the value will be, the pond level is at a reduced level of 158. okay, so it has to be in order to get the maximum seepage, the maximum loss will be 152, right? So it will be 158 minus 152, that will be 6. So 6 is the maximum seepage head. You can see that 6 is the maximum seepage head. Okay, and you can get the value of depth of the downstream cutoff pile, that turns out to be 152. It will be calculated from the downstream depth. Okay, downstream pile depth, that is 152 minus 141.7, it turns out to be 10.3. so from that you can easily get the value of alpha, and then if you get the value of alpha, we can get the value of lambda. So pi is known to us, that is 3.14. so easily H D, your H is 6 known to us, D have been found out, your lambda has been calculated, and accordingly we can get the value of exit gradient. Okay, so the exit gradient, it turns out to be, if you do the ratio, that is 1 by 9.53. if you do the ratio, that is 1 in 9.53. okay, also what you can do, you can use the graph for calculation. So how we will be using the curve? As we know, there is another curve like this. Okay, so for that purpose, what we have to do, we have to determine the value of alpha. Alpha has been determined. You can see that alpha is 5.53. okay, so we have to concentrate on this curve. Why this curve? Curve 1 is being considered because, just have a look, why this curve 1 is considered, because for alpha value, this represents your this particular curve represents, this is denoted by your alpha comma 1 by pi root lambda. Okay, this particular curve one, and this you can see alpha comma lambda, this is not required. So for that purpose what you have to do, for alpha equal to 5.53, this particular abscissa represents your alpha value. Okay, this particular abscissa, yeah, this axis represents your alpha value, and this represents your 1 by pi root lambda. This axis represents your 1 by pi root lambda. Okay, so what you have to determine, you have to get the value of alpha. So once you get the value of alpha, that is 5.53, you can see this recording is there, that's why, but have a look at the note I provided you. So here you can see that we will be determining the alpha. Okay, so after you get the value of alpha, that is 5.53, you will be drawing same like you did in the previous curves. What you have to do, you have to draw a perpendicular, then the point at which it intersects you have to draw a horizontal, and that particular value will give us this total value, that is 1 by pi root lambda. This total value you can get, and it turns out to be 0.18. You can see this turns out to be 0.18. Okay, so once you get the value of that, we can easily get this particular value, right? D is known, has been calculated by us, H is known to us. So from that also, from the curve also, we can get this value. So in order to avoid this calculation part, that is you have to get the value of alpha, then you have to get the value of lambda, then root lambda, like this you can easily get from the curve also. In this way you have to locate the point of alpha, and then from that alpha you have to draw a perpendicular to your curve 1, and that particular point at which it intersects you have to draw a horizontal to your y axis, and that ordinate will give us the value of 1 by pi root lambda. Okay, so in this way it has been calculated. Anybody having any doubt, you can ask me. Anybody can ask me anything if you have any doubt. There are two ways. One is through mathematical approach, you can do it. You can do it from the curve also. Anybody, have you understood? Yes or no? No response. Okay, I think the rest are not listening. Then what is the use of attending the classes if you are not listening? Okay, so only Pranab and Upasana have understood. Anyways, you can leave the class, and we will be starting with the next class, that is your environmental engineering. And right now it is 2:23. We will be starting at 2:25. Okay. Okay. Okay, Praneeth. So you can leave. We will be starting with the next class in 2 minutes.